And question number 10. 5, 6 देख लेते हैं पहले. And then we will look at question number 6. Sorry, question number 10 also. Fine. See, this is a very good question. Ethanol to acetone. Okay. So you make the structure of ethanol. That will be 2 carbon atoms and then OH. Okay. And you have to add some reagents here, and you are going to get acetone. So here in acetone we have 3 carbon atoms, and here we have 2 carbons, and here we have 3 carbons. Okay. So Aisha, can you tell me, if I want to go from 2 carbons to 3 carbons, there is a specific reaction that I have mentioned, and that is in haloalkene haloarine, if you remember it correctly. Do you remember that reaction, Aisha? If you want to increase 1 carbon atom, what to do? So you don't remember. See here. So first of all, you will convert this to, you will use SOCl2, and you will convert this to 1, 2 carbon atoms and then Cl. Then this haloalkene can be treated with KCN, right? As soon as you react this with KCN, that one you are going to get, oh, wait a second, it is acetone, no? My bad. Wait a second. I thought it is, wait a second, please. Not then this. I think this can be a bit longer, I guess. I can think of we can convert this to fine. It's going to be a long way, but that's what I remember right now. Okay, so please see. First of all, I can reduce it to benzene. I mean, oxidize it to aldehyde. So I will use PCC, and I will get CH3 and CHO. Okay. Now to this particular aldehyde, I will add a CH3 MgBr. CH3 MgBr. Now when I add CH3 MgBr, then what's going to happen? This particular. Here we have hydrogen, right? So this CH3 is going to attach on this carbon atom, CH3 carbon. This will become OH, and then this CH3, right? This Grignard reagent is going to attach on the carbon atom. Right? After this, what you can do? After this, you can oxidize it using what? Tell me, PCC or PDC or CRO3 use के लिए best होता है ketones के लिए CRO3. Okay, so 3-step reactions. Got it, Aisha? Aisha, tell me.
Yes, sir.
So this is the reaction. Okay, now let's look at the 6th one, that is CH3COCl. In the presence of H2PTBSO4. So obviously, this is going to be what? Converted to aldehyde. I hope this you were able to do, na? Rosenwald reaction.
Yes,
right?
sir.
This you were able to do. Then NH2OH, that is a reaction we have studied tomorrow, if you remember. I mean, not tomorrow, yesterday. Not, sorry. Day before yesterday. So here, what will happen? CH3, CH, double bond N, and then OH. Remember it now? So I just gave this reaction so that, I mean, if you were able to do, it's fine. If you're not able to do, see this reaction. Okay, if you're not able to do, that's fine also, because you have not explicitly done this reaction.
Okay.
You can identify the reaction now, yes or no?
Yes, sir.
Okay. Now, in the 10th one, which question you said?
Third B.
B part, third part, which part?
Third one.
Third. Okay. So benzoic acid to benzaldehyde. So if you want to go from benzoic acid to benzaldehyde, then it is like two-step conversion here. This one reaction you must not have learned, but you may recognize this. Okay, C double bond O, and then we have OH. Okay. Now, if I react this with thionyl chloride, SOCl2, if I react this with SOCl2, then this OH group will be replaced by Cl. The C double bond O is as it is, and it will be replaced by Cl. Okay. After this, what you are going to do? Same thing, Rosenberg reduction, PD in the presence of BaSO4 and H2. This will get converted to benzaldehyde. Got it now, Aisha?
Yes, sir.
So this reaction also, again, once again, we have not explicitly learned this reaction, carboxylic acid to acyl fluoride, but this I hope you can understand. Now, OH will be replaced by Cl, and if you have something like this, then also what happens? It is replaced by Cl if I react with SOCl2. Correct? Right, Aisha?
Yes, sir.
Okay, chali. Now, guys, please write. So we were looking at nucleophilic addition reactions of aldehyde and ketones, and we have seen for ammonia, but we did not actually write anything. So addition of ammonia and its derivative is the section and the first reaction. And in this, first of all, we'll react with ammonia. A part will be reaction with ammonia. Reaction with ammonia. What is ammonia? Ammonia is NH3. Okay, so I will write here, it forms imine. ठीक है, जो प्रोडक्ट आता है उसको क्या बोलते हैं? इमाइन बोलते हैं. So I am writing a generalized thing here, C double bond O, two groups like this, okay, plus NH3. Now I hope you remember from this from the last class, C double bond N, and it will be attached with hydrogen. It will be attached with hydrogen. So two hydrogen, you have to remove two hydrogen and attach whatever is remaining. So for example, if I react with CH3 CHO, second guys. If I react this with CH3 CHO, then what's going to happen? You see, CH3 CHO plus NH3. So CH3 will be as it is, the CH will be as it is, and oxygen and two hydrogens from here, it is going to get away, and you will get double bond N bonded to H. Similarly, if you have a ketone like this, plus NH3, this is going to give you double bond. Here you will get what? Nitrogen and then H. If you get something cyclic, then also you don't have to worry. Double bond O plus NH3, H2 will be removed, two hydrogens from the ammonia and oxygen from the, then you will get double bond N and then H. All of you got this? Yes or no? Please tell me.
Yes, sir.
Okay. After this, I am going to write only these reactions, okay? The generalized form, and then you are going to write all of these three. 1, 2, 3. Okay? 3. Is everyone done? Yes or no? Please tell me.
Okay.
Done? Or wait, what did you say, Aisha? Done, na? Okay. Let me know if someone is writing. After this, please write B part. Reaction with amine. The writing. Okay.
Yes, sir.
Sorry, what? I could not hear that.
Yes, sir.
Done. Write the B part. Reaction with amine. What is amine? It is going to be, you will have RNH2. Hai na? So I will rather write it as NH2 bonded to R. Okay. So please write forms substituted amine. First substituted imine. Forms substituted imine. And it is also known as Schiff's base. SCHIFFS apostrophe Schiff's base. Okay. So Schiff's base, it is a term that you have to remember that it is a substituted amine. There is a question in NCERT regarding this. You have carbon double bond O, two bonds like this. Okay. Plus you have H2 with nitrogen and then R. So obviously what's going to happen? You're going to have carbon double bond N, which will be bonded to R. So this H2O will be getting away. Now, if you have CS3 in place of R, you will write CS3. So please remember that also. Don't just write R, okay? Please use your mind while you're writing the product. You have to look at the pattern and then write the product, okay? Don't write the products exactly. H2, N bonded to CS3. That will be the product. Similarly, if you have something like this, double bond O plus H2, N bonded to CS3, what will be the product? Yeah, Parker, you have to send me. You have to send the answer on my WhatsApp. Parker, first one is correct. Very good. Yeah, both of them are correct. Very good, Parker. Write the C part. Reaction with hydroxylamine. Reaction with hydroxylamine. Hydroxylamine is H2 bonded with nitrogen and then OH. Please write, it forms oxime. Back में लिखिएगा ketoxime, ketoxime and aldoxime. Okay, sorry, aldoxime. In general, we call it oxime, but when the oxime is made by an aldehyde, it will be aldoxime. If it is made by keto, it will be ketoxime. So general reaction will be C double bond O plus H2. Even if I write NH2OH ना तो घबराना नहीं है आपने. Okay, if I write like this NH2OH, इस पागल में तो जाएगा बिल्कुल. You have to remove H2 from here and oxygen from here. So carbon will be as it is, double bond N, and then which is bonded to OH. That's it. Okay. Now please send the answer for these two guys. What happened? I did not get answers from anyone other than Mariam. Send the answer for the previous one, then I will do the next one now. Alia has sent. Say yeah, Alia. It's fine. Second one, yeah, correct, Alia. Others, please send now. Hafsa, please send the answer. Yes, Mariam Khatun, very good. This one is correct. Hafsa and Aisha, please send your answers. And send me, like, if you have not done anything, please let me know that you did not understand. Also, why were you guys not present in the solutions class today? Aisha, have you done solutions? No, no. Aisha?
Yes, sir.
So why were you not present in the solutions class today? Hafsa, can you see a mistake in the CH3CHO1? There's a mistake in the CH3CHO1. Can you identify that? Again, Aisha, why is there? Aisha, am I audible?
Yes, sir.
Yes, tell me CH3C double bond N. And then what is that bond that is going down? It's bonded to N of the another compound. What is that bond going down? Why the hydrogen is not there? So you have to only remove oxygen from the carbonyl carbon. No? So you have to write CH double bond N. Okay. Similarly, Hafsa also you have done a mistake. See the previous, how I have done. Whatever, wherever the double bond O was there, you remove that double bond O. In place of that, you write N. Carbon will be directly bonded. Whatever is present on carbon, that will be present. Also, you can look at the previous one. See here that CH is still there. No? The aldehyde CH is still there. You don't have to remove that CH. Okay. Aisha, you got this? Yes or no? Tell me.
Yes, sir.
Hafsa, can you please turn your mic on? Hafsa,
Yes,
can you please? You got the mistake?
Yes, sir.
What is the? Can you please correct and tell me? It will be CH3, CH, and then O.
No, sir. Should be double bond with N.
Double bond N. CH should be there, but O should not be there. Actually,
Yes.
that's good that you understood that. Now, similar questions only. Okay, don't worry. It's just a practice to write all of these reactions. All of these are similar only. Okay, you don't need to remember them, but you have to have a habit. Okay, have to have a habit that you, when you are given the molecule, then you can remove the H2 from the ammonia derivative and oxygen from the carbonyl carbon. Right, next CH3, CHO plus NH2OH. For aldehyde, for ketone, you can write double bond plus NH2OH. And quickly do these reactions. You will get only, what I will say, 2 more minutes. After this, we'll see the D part. Reaction with hydrazine. Formula for hydrazine is something like this. NH2, NH2. मरियम, आपका तो फोन बहुत खराब हो गया है ना पार्कर जी? हाँ पार्कर, कैमरा आपका खराब हो गया बिल्कुल फोन का। वैसे समझ में आ रही चीज? इट्स फाइन, आंसर इज करेक्ट। आई कैन सी दैट। मरियम खातून, very good, Mariam Khatun. Perfect. Others, please send the answers. Then you will see reaction with hydrazine. So hydrazine forms hydrazone. Forms hydrazone. I think this is Hafsa. Hafsa, yes, now it is correct. Very good. Aisha has not sent the answer. Alia has not sent the answer. Please send your answers, guys. Hydrazone. Okay, so you have carbon, double bond O plus NH2, NH2. So next here is carbon, double bond N. Now what is attached to N other than H2? It is NH2. Alia, double bond O. Yeah, that's fine. Correct. Correct, Alia. Yes, Aisha, correct. By the way, Alia and Aisha, just telling you guys, you can write it like this. Okay? CH3, CH as it is, double bond N, and then see other than H2, what is attached to H. Okay, so you can write CH. You don't need to write another bond here and show that it is CH. If you're just doing it for your purpose, it's fine. Okay, अगर आप sorry, my bad, ये हमने क्या बना दिया? अगर आप खुद के लिए कर रहे हैं, then that is fine. Don't worry. But if you're doing for the examiner, then don't do it. CH double bond N लिख दीजिए, काफी होगा. Now for hydrazone, please write. If you have something like this, CHO plus NH2, NH2, and if you have something like this, ketone, double bond O plus NH2, NH2. Okay, so again it will be same only, you know, remove the oxygen, then add double bond N, and then see what is there other than H2. Same thing, nothing is different here. Oh, Send your answers quickly, guys. If you are getting confused, just look at the number of carbon atoms that you have drawn. That should not be changed. Alia has sent the answer. Yes, Alia, first one is correct. Second one is also, yeah, fine. Okay, Hafsa has also sent the answer. NH2 and NH2. Yeah, very good. NH2. And then Mariam Fatum, double one and NH2. Yeah, very good. Correct. Fine. So here you will have 1, 2, 3 carbon atoms, CH double bond N, further bonded to NH2. And here you will have double bond N, further bonded to NH2. Okay. I hope this is fine, right? No problem till here, yes or no? Tell me, guys.
Yes.
No problem, no? Okay. Next we have DE, which is also very similar. Let me see who has sent the answer. Aisha. Aisha, you missed the CH. Aisha,
Yes, sir.
CH है ना, उसको थोड़ा ध्यान रखिए, आप भूल जा रही हैं, कैसे चलेगा ऐसे? ठीक है, चलिए, write the E1. So even though there is a list of reaction like this, but all of them are very similar. Okay, you don't have to worry. Reaction with phenyl hydrazine. Reaction with phenyl hydrazine. Please see what it will forms phenyl hydrazone. Forms phenyl hydrazone. You have carbon, double bond oxygen, plus NH2 single bond, NH2 single bond NH, singly bonded with a benzene ring. That is the phenyl group. Okay, so here also the same thing is going to happen. We'll have carbon, double bond, I mean the single bonds as it is, double bond N, and this N is further attached to NH, which is further attached to benzene ring. Okay, so write the reactions now. CH3, CHO plus NH2, NH, benzene ring, चलिए इसके लिए आपको दिया जाएगा 3 मिनट, है ना? आई थिंक 3 मिनट would be enough. 3 means 3 for Hafsa. Okay, 3 minutes.
Yes, sir. I know it.
So you know it. आपकी क्लास में एक लड़की है हसना नाम की, राइट? शी इज आल्सो फ्रॉम श्रीलंका, आई थिंक, राइट हफ्सा?
Yes, sir.
वो आई थी, पता नहीं, फिर उसने फिर वो नहीं कंटिन्यू करने लगी. आई डोंट नो व्हाट हैपेंड. शी वाज देयर फॉर a few classes, not in your batch but in some other batch.
Okay. Sir.
Are you guys friends or just classmates? Because she
No,
knows
sir.
you.
She's my friend. Yes, sir.
Sorry?
She's my friend, sir.
Yes, she's your friend only.
Yeah.
But उसको आपने नहीं बताया लर्निवियो के बारे में, उसको कहीं और से पता चला.
Sorry, sir.
You did not tell her about Learnivio. She got to know about it from somewhere else.
Yes, sir.
ठीक है, everything is. पारकर बताइए क्या गलती है? पारकर, what is the mistake? हाँ जी पारकर.
बेंजीन रिंग.
हाँ, रिंग ही नहीं है बेंजीन में, कैसे चलेगा? आंसर गलत हो जाएगा ना फिर तो। ओके, हम एक और बना देते हैं आप लोग के लिए, ठीक है ना। हाउ दिस कैन ऑल्सो बी रिटन, प्लीज सी। So this benzene ring can also be written as pH. So you can have NH2, NH bonded to pH. Okay, so you will write, I mean, even for these also you can write it like this: double bond N further bonded to NH and then to pH. pH has small h. Okay, so if you don't want to make the benzene ring, you can write pH. C double bonds. Yeah, correct. Very good, Mariam. Alia. NNH, NNH, and phenyl. NNH and phenyl. Yeah, very good, correct. Second one, NNH and phenyl group. Yeah, very good. So if you don't want to write, you can write it like this also: CH3, single bond CH, double bond N, further bonded to NH, and then pH. Here also you can write like this: double bond N, further bonded to NH, and further bonded to pH. Aisha. Correct, Aisha. Very good. CH and correct. Very good. No. Right, next. अब इसी में like in the same phenyl hydrazine there is a, please write F part. It just becomes a bit bigger now. Okay, so reaction with 2,4 dinitro phenyl hydrazine. 2,4 dinitrophenyl hydrazine. We call this 2,4-DNP. We call this 2,4-DNP. Please write, it forms 2,4 dinitro phenyl hydrazone. So what happens here, please see. You have carbon doubly bonded to oxygen, two groups like this, plus you have NH2, NH bonded to benzene ring. Then you have NO2 here and NO2 here. So what you are going to get? You are going to get carbon, the double bond as it is, doubly bonded to nitrogen. कुछ घबराने वाली बात ही नहीं है, just छापना है आपने. You just have to make the drawing whatever is given. N, this H2 has gone, bonded to NH, further bonded to benzene ring. Now this benzene ring has NO2 and NO2 here. The second position and the fourth position. Okay. Actually, please write CH3, CHO plus this molecule. ठीक है, इसको तो हमने ऐसे दे दिया है. अब देखिए अगले वाले में I will write the reaction of acetone with 2,4 DNP. And do these two problems. Then everyone, yes or no, please tell me. Send your answers when you are done, okay? Acetone, I hope you remember what is acetone. Acetone भूल गया मैं तो बहुत खराब बात है. Mariam Parker, double bond N. Yeah, very good, correct. Others, please send the answers now. CS3, CS, and yeah, very good, Mariam. Patoon, very good, Alia. For DNP, CS3, CS3, C, CS3, या ठीक है, थोड़ा सा लिखना आपने गंदा बना दिया, क्या बोलते हैं, आलिया, है ना? कार्बन को इतना बड़ा बनाया आपने, बेंजीन को इतना छोटा. CS3, CHN, ठीक है, ठीक है, वेरी गुड आलिया, इट्स फाइन. थोड़ा सा क्लमजी टाइप सा हो गया, लेकिन इट्स फाइन. See here, so it is going to be CS3. बॉन्ड लाइन कर लेते हैं ना अपना फेवरेट. CS3, CH, डबल बॉन्ड N. क्या खूबसूरत, हमको तो बॉन्ड लाइन से एकदम बिल्कुल मोहब्बत. Just love bond lines. N हो गया, and which is bonded to NH. इधर NH हो गया, हमें मस्त आपके पास बेंजीन आ जाए. बस हो गया, हाँ. I hope this is not very difficult for you guys to understand. CS3, CH double bond N, further bonded to NH, further bonded to the DNP thing. Okay. Then you have the acetone. What is acetone? CS3 and 3 carbon atoms. In the middle, you have a ketone. So plus you have the DNP, 2,4 DNP. So you can write it like this also. Now, after this, you can make double bond N, further bonded to NH, further bonded to the benzene ring, and here NO2. All of you got this? Yes or no? Please tell me. अब देखिए आप, the last reaction here is the G reaction. I think this is. Am I audible, guys? Is my voice clear to everyone? Reaction with. Please write a reaction with semi-carbazide. Reaction with semi-carbazide. Okay. Now please write it forms semi-carbazone. Forms semi-carbazone. And write the reaction. You have carbon doubly bonded to O, plus we have NH2. Actually, एक बार मैं दिखा दूं सारे notes. NH2 further bonded to NH, further bonded to C double bond O, and then NH2. Okay, so in this case, what happens? This particular nitrogen atom, it attacks, and this hydrogen is gone. So we have carbon double bond N, further bonded to NH, further bonded to C double bond O, and then NH2. चलिए राइट दिस डाउन, ठीक है। सो घर में कर लीजिएगा आप लोग, है ना। आई होप दिस नॉट गोइंग टू बी डिफिकल्ट, सो घर में कर लीजिएगा। इसके बाद वी विल राइट सम रिमार्क्स, ओके, प्लीज राइट सम रिमार्क्स। Let me know if all of you are done writing, then I will start with remarks. All of you done writing ना the questions? ये मतलब जो जवाब है आप लिख के हमको भेज दीजिएगा बाद में, अभी रिमार्क्स लिख लीजिए, ठीक है। Please write the remarks. First of all, please write 2,4 DNP, 2,4 DNP on reaction with aldehyde and ketones, aldehyde and ketones gives yellow, orange or red solid, yellow, orange or red solids. Therefore, these are used as test for identification of aldehyde and ketone. Okay, aldehyde and ketone. So for example, if you have A, there is some compound A, we don't know what it is. And if you react this with 2,4-DNP, and it is going to give you yellow, orange, or red color solid. And if it gives you that, then we can say that this is going to be aldehyde, or it can be a ketone. It can be aldehyde or it can be a ketone. All of you got this? Please tell me. ये समझ में आ गया सबको? हाँ या ना? अरे बोलो भाई.
Yes, sir.
Thank you very much. Now please write next point. In reaction with semi-carbazide, there are two NH2 groups, but reaction with aldehyde or ketone is only possible from one of them. Because the NH2 adjacent to carbonyl carbon is in resonance, and its lone pair electron is not localized. ठीक है, क्या कहना चाह रहा है? What is semi-carbazide? Please see here. NH2 bonded with NH, further bonded with C double bond O, further bonded with NH2. So here we have two NH2 groups, right? We have this blue NH2, we have this blue NH2, and then we have this red NH2. Both of them are having lone pair electrons. This is also having lone pair electrons, but this lone pair electron, it is involved in resonance. Okay, so this one is involved in lone pair is delocalized. due to resonance. And here this lone pair electron, localized lone pair electron, therefore acts as nucleophile. All of you got this? Someone please tell me.
Yes.
Okay. Right, next. We can move forward, right? Yes or no? All of you have written this?
Yes, sir.
Okay, fine. अच्छा, आलिया is writing. आलिया माइक ऑन करके बोल दिया करें. Then yeah. Now this is the first reaction. Okay. And in this first reaction, we have plenty of reactions inside this, which are in the similar pattern, same pattern. Now the second reaction, that is nucleophilic addition reaction, is the addition of hydrogen cyanide. Addition of hydrogen cyanide. That is HCN. Is right. Aldehyde and ketones reacts with HCN to form cyanohydrin. Okay. Right, next point. HCN on its own reacts very slowly. Hence a base is used as catalyst. Hence a base is used as a catalyst. So we have first of all HCN, and if there is a base, then this base can abstract the H plus ion. It will make H2O plus Cn negative, right? Now Cn was neutral, Cn negative is a charged molecule, that is why it will be reacting faster. So we have carbonyl carbon like this. Plus we have Cn negative, so it is going to be C triple bond N. Now carbon will have negative charge, nitrogen will have the lone pair electron. Carbon will be delta positive because of its bond with electronegative oxygen atom. And this is going to attack like this. And this bond is going to break. And you will get something like this. Carbon with the two bond as it is. Now here we have added a new bond, which is the Cn bond. And here I have the O negative bond. Now this is obviously an intermediate. It does not stay like this for a very long time because we have HCN and H plus will be here everywhere. Now H plus is going to attack on the O negative, and you are going to get the two carbon atom, the two bond as it is, bonded with OH. And then Cn. Okay, so basically the reaction which is happening here is we have carbon with double bond O, carbonyl carbon plus HCN plus HCN. It gets converted to carbon. The two bonds are as it is. There's nothing happening to those two bonds. And we are getting added a CN and a OH group like this. Okay, so this is cyano. And here we have hydrogen, cyanohydrogen. Okay, so right, for example, if you have CH3CHO plus HCN, then this CH3 will be as it is, this CH will be as it is, and this carbon will get a CH, and the oxygen will become OH. Okay. Similarly, if you have a ketone, something like this, plus HCN, then the O double bond O will become OH, and the carbonyl carbon will get added. One more thing, that is CN. All of you got this? Yes or no? Please tell me.
Yes, sir.
Anyone still writing? Anyone still writing? No, fine. Now moving on, please write next. Addition, third one, addition of hydrogen sulfide. Third is addition of hydrogen sulfide. Now, in hydrogen sulfide, please see, please write. First of all, write the statement: aldehyde and ketones react with NaHSO3 to form bisulfite addition product. Bisulfite addition product. Now let us look at the reaction. We have the two bonds of carbon as it is, double bond O, plus we have NaHSO3. NaHSO3. So obviously here the sulfur is going to attack on the carbon because it is in the central atom and also having lone pair electrons. So the carbon atom will be added with SO3H on one side, and on the other side it will be having O negative with Na positive, ONA. Now after this, what is going to happen? Will be a proton transfer because oxygen is very large. Oxygen will attack on this hydrogen atom, and there will be proton exchange or proton transfer. We say it is proton transfer. It is very fast and it interchangeably happens always, but it is favorable towards the position where you have OH. So SO3Na, and here you have OH. That's the reaction. That's it. So if you have something like this, CH3 CHO plus NaHSO3, this is going to give you, see, the carbon atom, it is having a CH3 group and a hydrogen group, right? And here you will have SO3Na, and here you will have OH. Similarly, if you have something like ketone plus NaHSO3, then the ketones, two carbon atoms will be as it is. The oxygen will become OH, and this will become, or rather, let me write this OH here and SO3Na here. That's it. I hope you guys understand this, yes or no? It's not very fast now. Tell me if it is fast, please let me know. Okay. I'm just expecting that you guys will be able to understand since we are in the third chapter of organic chemistry. If you don't understand, no worries. Okay, I will go slow. Okay, Alia, Aisha, Hafsa, Mariam Khatun, and Mariam Patel, please let me know if you seem I am going too fast. Done, everyone? Yes or no? Please tell me.
Yes, sir.
Okay, just a second. Right. Send the answer for this one. Okay, Mariam, Patu. SO3 very good. आप करना delete कर दें message. See here guys. पार्कर ने भेजा फिर से. SO3 Na होगा पार्कर. Na मिस कर दिया आपने. Na and OH. आलिया. SO3 Na. हाँ very good. It's fine. ठीक है, बहुत आसान रिएक्शन है ये सारे. All of you got this? Yes or no? Please tell me. Now write the fourth one. A reaction with Grignard reagent. And you have seen this reaction already in the method of preparation of alcohol. Grignard reagent. Okay, please write. Aldehyde and ketones react with Grignard reagent. So what is Grignard reagent? It will be RMgX. Aldehyde and ketones react with Grignard reagent and forms corresponding alcohol. Corresponding alcohol. Corresponding alcohol. Okay. So I hope you guys remember this. And I'm just hoping that you guys will remember this. So we have C double bond O plus RMgBr or RMgX for that matter. And in the second step, we are going to add H2O in the presence of H plus, or you can just write H2O in the presence of H plus like this, or just H2O also. And you will get the two carbonyl groups are as it is. Here you will get the R group and here you will get the OH. Okay. So I hope you also remember that there are only three cases which can be formed. You can either have H carbon and both these are H and H double bond O, or you can have these groups as, wait a second, let me just copy this. Okay, and if I react this, हाँ बोले सर को मजा आ रहा है डायग्राम बनाने में, ये हमारी जान जा रही है ऑर्गेनिक केमिस्ट्री से, सर को खेल सूझ रहा है आप ना, बट आई लाइक ब्यूटीफुल थिंग्स. So symmetric, you know. So we will react all of these with CH3 MgPr. Okay. So for the simplicity's sake, CH3 first step is going to be CH3 MgPr. Second step, it is going to be H2O in the presence of H plus or just H2O. Okay. So here what's going to happen? Here the two hydrogens will be as it is. This will become OH, and here we will get CH3. Here we have hydrogen and here we have hydrogen. What's going to, oh my bad, my bad. अब इसमें तो ये change हो जाएगा ना. This will be R or rather CH3 आप लिख दीजिए. And here you write both of these are CH3 and CH3. Okay. And the second case, what is going to happen? We'll have CH3 and then carbon hydrogen. So that CH will be as it is, and then double bond O will become OH, and this carbon will get the CH3 from Grignard reagent. If I talk about this one, it is going to be CH3 bonded to carbon atom, which is already having one bond with CH3 like this, and there will be OH here, and one more bond with CH3 that will be from the Grignard reagent. Okay. I hope you have seen this reaction. Yes or no? Please tell me. Hafsa, Mariam, Parker, Aisha, and Alia. All of you have seen this reaction. Yes or no? अरे बोल दो भाई, देखा है ना सबने ये रिएक्शन तो.
Yes, sir.
आयशा की तो अलग ही दिक्कतें हैं सर. कैन यू स्क्रॉल अप लीजिए. स्क्रॉल अप कर दिया हम. Done guys. Yes or no? Please tell me. ठीक है. सो एक रिएक्शन है जो अभी हम लोगों ने नहीं पढ़ा है, बट उससे पहले आई वांट टू डिस्कस द रिएक्टिविटी. ओके. आफ्टर दैट वी विल डिस्कस that one reaction in the next class, that is the addition of alcohol. लेकिन उससे पहले, because आपका test assessment होगा, and assessment में an important portion is the reactivity of aldehyde and ketones. Okay. So maybe leave one page. Okay. One page or 1.5 page. A4 size अगर आपके पास है, one page आप छोड़ दीजिए. उसके बाद ठीक leave one page. And then write the topic. Reactivity of aldehyde and ketone. Reactivity of aldehyde and ketones towards nucleophilic addition reaction. Towards nucleophilic addition reaction. Nucleophilic addition reaction. Okay. Please write reactivity towards nucleophilic addition reaction is directly proportional to addition reaction. It is directly proportional to electron deficiency of carbonyl carbon. ठीक है. So the carbonyl carbon जितना ज्यादा electron deficient होगा, the nucleophile will be attacking it very easily. Will be attacking it very easily. ठीक है. First thing is that. Also, I can say that it is inversely proportional to the steric hindrance. Inversely proportional to the steric hindrance. Because the nucleophile has to come and donate the electrons to make a bond. So if there will be a steric hindrance, then obviously it is not going to attack on the carbonyl carbon very easily. So basically attack क्या होता है देखिए यहाँ पे. You have R. I am looking at aldehyde and ketone both. So C double bond O, and we have hydrogen. Simple. Also we have R, C double bond O, and here we have R dash. So the one is aldehyde, and the other one is ketone, aldehyde and ketone. See here, if we are having nucleophile, nucleophile is going to attack here. Okay. Now let us talk about both of these things regarding their electron deficiency and their steric hindrance. First of all, let us talk about the electron deficiency. Now, obviously, the carbonyl carbon is electron deficient because electron deficient means it is electron poor because it is attached with oxygen atom with double bond. So this will be delta positive. Here it will be also delta positive. Just a second, guys. Just a second, guys. Okay. Now both of these are delta positive. Now let us look at the electron deficiency other than the carbonyl carbon with its attached to oxygen atom. So in aldehyde, there is one alkyl group which is giving it electrons. That is why what is happening? The electron deficiency is getting lowered. It is getting lowered because one alkyl group is giving electron to the carbonyl carbon. But if I look at the ketone, then here we have two alkyl groups which are giving electrons to the carbonyl carbon. There, that is why the electron deficiency is even getting less. Deficiency कम होते जा रही, मतलब उसको इलेक्ट्रॉन मिलते जा रहा है, तो वो बोल रहा है कि हमको तो इलेक्ट्रॉन मिल रहा है, न्यूक्लियोफाइल से जरूरत नहीं है हमको, है ना, वो ऐसा बोलेगा. We'll start to say that I am already getting electrons from my alkyl group, so I don't need any electrons from the nucleophile. Huh? So it will become what? Less electron deficient. It will be becoming less electron deficient. Okay, the ketone. So first point that I will write here is this is about aldehydes. Okay, this is about aldehyde. We can write only one alkyl group is present. Therefore, more electron deficient than ketone. But if I look at ketone, then it has two alkyl groups present in ketone make the carbonyl carbon less electron deficient. Okay. Another thing which you can very easily see is that nucleophile has to come and attack aldehyde, and it has to only face one alkyl group, one bulky group, and the other atom is very small, hydrogen atom. But here we have two bulky groups. That is why it is going to be less reactive. Huh? So next point is that this is less hindered. This is more hindered. Okay. So therefore we can write a conclusion. Aldehydes are more reactive towards nucleophilic addition reaction than ketones. All of you done, guys? Yes or no, please tell me.
Yes, sir.
Right, next. Next, right. Benzaldehyde. Okay, so when you look at benzaldehyde, its reactivity will be even less. It will be so less that it sometimes does not even react very easily. It does not react at all sometimes. Okay, so please write benzaldehyde and acetophenol. Or rather write it like this. Don't easily nucleophilic addition reactions. Don't easily give nucleophilic addition reactions because the carbonyl carbon is less electron deficient. अच्छा एक वर्ड और होता है इलेक्ट्रॉन डेफिशिएंट के लिए इलेक्ट्रोफिलिक, ठीक है ना, लेस इलेक्ट्रोफिलिक, is less electrophilic due to resonance. Due to resonance. Okay, please see what happens actually. You have carbon, double bond O, and there is some group here. Okay, I mean, no matter whether it is benzaldehyde or acetophenol or any other thing, you have C double bond O and some group is here. You don't want to worry about that particular group. But what happens here is, please see, this bond moves here and this pi bond moves towards oxygen atom and giving you a structure which is like this. Pi, pi, and here you will get a positive charge, double bond with carbon atom, and then single bond with oxygen negative. Okay, and this group is as it is, whatever that group is, hydrogen or any alkyl group. Now, see here, guys. As you can see here, we are getting a O negative charge here, and the carbon is having a pi bond. Now, imagine why, if you are going to make some other structures also, that will be fine. You can make other structures, but the resonance hybrid that we can understand from here is that this, here you have partial double bond, carbon, oxygen, and some bond is here. Even this bond is what? Partial double bond. Even this bond is partial double bond. So obviously nucleophile is not going to attack on the carbon which is having partial double bond, because partial double bond means existence of pi electron, and pi electron is going to be what? Pi electron is going to be obviously electron rich, and that is why the nucleophile cannot attack. Okay, so please write this down. There is also a question in NCERT regarding propanol and benzaldehyde. That is an example question. Please read that section on reactivity of nucleophilic addition reactions, and then you will understand it also. Okay, so you'll see the question, then you can understand how the questions are being framed. But I hope from here you can see that the carbonyl carbon in benzaldehyde and acetophenol, both of them will be having partial double bond. And if they are having partial double bond, then what's going to happen? Then it is going to be not attacked by the nucleophile. And also, if it is having a double bond, then obviously it is not a electrophile. It is not electrophilic. All of you wrote till here, yes or no, please tell me.
Yes, sir.
You have seen the message. The test will be activated 10 minutes. Okay, so once it gets activated, please attempt those tests. That test, okay? It will be on this particular topic, nucleophilic addition reactions only. Okay. So